All right, this is section 5.6, part 4. Now, we need to figure out what happens at the x-intercept. So at this spot right here, what happens? Does the graph go through that point, or does it touch it and bounce off? And we need to look at this right here. We could put parentheses around it. This has a multiplicity of 1, so it's going to go through that point right there. So looks like the graph is going to do something like this right here. Go towards that asymptote, comes through this point, and then goes right here. Okay. Now, we could check if we have anything over here in this spot. Now, I know that we're not going to have something like this, because if we did, we would have another x-intercept at this point or somewhere along that line. We would have another x-intercept. And since we don't have another x-intercept, we need to check to see if we have anything up in this little spot right here. Now I'm going to check for, let's see, this is 1, 2, 3, 4. I'm going to check x equals -5 and see if we have anything there, which looks like we should. So f of -5, so that's going to be 2 times -5 minus 3. Minus 3 all over x, well, -5. -5 plus 4. So that's -10 minus 3, and that's -1. So that's -13 over -1. So that is 13. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we do have a point somewhere up there. Okay, so what it would look like, I can get rid of this. We've got an asymptote right here and right here. So the only thing that our function can do is go towards both of those. So go towards this one and then curve, and then here it is right here. Okay. So there is my very rough sketch of this function right here. Okay, now let's move on to this one, and we'll go ahead and find the y-intercept. So x equals 0, so f of 0, 3, 0 squared minus 14 times 0 minus 5 over 3, 0 squared plus 8 times 0 minus 16. So it looks like we got -5 over -16. So 5 over 16. Okay, so we've got a y-intercept of 0, 5 16ths. And then x-intercept, so y is equal to 0. So 0 equals 3x squared minus 14x minus 5 over 3x squared plus 8x minus 16. Don't care about that. So 0 equals 3x squared minus 14x minus 5. I can't factor anything out, so I'm going to use the shortcut method of finding this. Okay, so we have 0 is equal to x and x. The only thing I can break x up into, let's see, we've got maybe 15 and 1. So we would have -15 and +1. What I took out of it, I need to put back in here. Okay, so I have 0 is equal to x plus 1/3 and x minus 5. Okay, so x plus 1/3 equals 0, so x equals -1/3. X minus 5 equals 0, so x equals 5. So my x-intercepts are -1/3, 0, and 5, 0. Okay, so let's find the vertical asymptote. So I'm going to set this equal to 0, and I'm going to factor it using the shortcut method. So it'll be minus 48. Okay, so break that down. So x and x. Looks like I can use a 12 and a 4. So I need, let's see, negative 4, positive 12. 12 times negative 4 is negative 48. 12 minus 4 is 8. Okay, bring back what I divided out. So I've got x plus 4 and x minus 4 over 3. So it looks like I'll have two vertical asymptotes. So x equals negative 4 and x equals 4/3. So we've got x equal to negative 4 and x equal to 4/3. Okay, now let's find the horizontal asymptote. Okay, so the horizontal asymptote. Okay, so I need the degree of the numerator, which looks like 2. The degree of the denominator also looks like 2. So when they are equal to each other, what we do is, so it's this one right here. We're going to take the ratio of the leading coefficients. So the coefficient for the first one is 3, and the coefficient for the second one is 3. So this is 1. So I have a horizontal asymptote, y equals 1. Okay, here's the factor form of our function. Notice everything has a multiplicity of 1. Okay, so we're going to try to plot this. Okay, and I'm going to go out to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I'm going to plot 5 over 16. I'm going to grab my calculator and see what that's close to. So for 5 over 16, I get something 0.3125. So I'm going to go halfway and then just a little bit lower. So we'll say about there for our y-intercept. Okay, so there's our y-intercept, and then our x-intercepts we have negative 1/3, so about there. And we also have 5, so here as well. We have a vertical asymptote at x equals negative 4 and 4/3. Okay, so 4/3, that is 1 1/4. So that's about here. Okay, so we'll have an asymptote right, shouldn't put a point right there. That's an asymptote, so about here. And then we have a horizontal asymptote at y equals 1, so about there. Okay. So I can be pretty sure about what's going on in this little slot right here. Looks like we're going through right here, get close to the asymptote, and then go through, because at that point, which is 5, which is talking about this right here, it has a multiplicity of 1, so we should go through that point. And I know that the graph is not going to do something like this, because otherwise I would have another x-intercept, and I don't. So we know it's not going to do that. So it should be somewhere up here like this. You can always have a point to check to see if that is true. So you could take, say, what is that? 1, 2, 3, 4, 5. X equals 5, and see if you did get a point. And you should, because the only points that you can't have are negative 4 and 4/3. Those are your asymptotes. Now I need to know, does my graph do this number, go through these points right here, and then kind of turn down? Well, actually, it wouldn't do that. And we know it wouldn't do that because we would have another x-intercept right here. And since we don't have that, we know it's got to go up through these 2 points right here, and then get closer and closer to this asymptote. So it looks like it will do something like this right here. Now we know it's supposed to go through this point right here because that would be this point right there. And that has a multiplicity of 1, which means you should go through that point. So that is a very rough graph of this function. Not this one, well, the same one. That's just factor form. But of this function right here. All right, now let's graph this one right here. So I'm going to find the y-intercept. So x is equal to 0. Okay, so that's going to be f of 0 is equal to 0 squared minus 0 minus 6 over 0 squared minus 4. So it looks like I have negative 6 over negative 4. Cancel out the negatives, take out a 2, so 3 over 2. Okay, so we have a y-intercept of, 3 over 2 comma 0. Oh, I have that backwards. 0 comma 3 over 2. Okay, now let's find the x-intercept, which means y is equal to 0. So we have 0 is equal to x squared minus x minus 6 over x squared minus 4. Don't care about that. X equals x squared minus x minus 6. So we're going to factor that. So x and x looks like 3 and 1. Negative 3, positive 1. Negative 3 times positive 2 is negative 6. Negative 3 plus 2 is a negative 1, if that works out. So we have 0 is equal to x minus 3. So that gives us x equal to 3. And then x, so 0 equals x plus 2. So x equals negative 2. So we have x-intercepts at 3, 0, and negative 2, 0. Now let's find our vertical asymptote. So I'm going to factor this. X squared minus 2 squared. That's the same thing as x minus 2, x plus 2. So we're going to set those equal to 0. So x minus 2 equals 0, and x plus 2 equals 0. So x equals 0 or 2, and x equals negative 2. Now, before I say that these are both vertical asymptotes, let's look at the factor form of this. We had x minus 3 and x plus 2. And we have x minus 2x plus 2. Now notice how we can cancel out the x plus 2. So that means that this right here is my only vertical asymptote. And if we had solved that for 0, which we did right here, we get x is equal to 2. So we have a vertical asymptote of x is equal to 2, but we also have a hole that is going to be x is equal to negative 2. Okay, so let's find our horizontal asymptote. Okay, so the horizontal asymptote, so the degree of the numerator is 2, degree of the denominator is 2. So we're going to take the leading coefficients, with this one is 1 and this one is 1, so it's 1. So horizontal asymptote at y is equal to 1. Okay, now before I erase this, I want to show you that the multiplicity of everything is 1. So that means that within our x-intercepts, we're going to have the graph go straight through those points. Okay, so let's get rid of that now. Okay, so let's plug in everything we know. And I'm going to go out to, looks like 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we're going to have